Jordan is playing a computer game in which they shoot at drones and cruisers. The number of drones they hit per minute can be modeled by a Poisson distribution with the mean 5.7. Poisson distribution. Remember, define a random variable. The number of cruisers they hit per minute can be modeled a Poisson distribution with the mean 3.9. Any single hit occurs independently of all others. Find the probability Jordan hits at most 12 drones in 2 minutes. For Poisson distribution, the mean or the rate is very important. Per minute. Here, 2 minutes. So we define D follows Poisson distribution with 5.7. C follows Poisson distribution with the mean 3.9. Within 2 minutes, let's do D1 follows Poisson distribution with 5.7 times 2. We are looking for probability of D1 less than or equal to 12. Go to Poisson CDF. Lambda is 5.7 times 2. Lower bound is 0. Upper bound is 12. Enter, enter. Answer is 0.644. A2, a total more than 11 drones and cruisers in 1 minute. C plus D follows Poisson distribution with 5.7 plus 3.9. We are looking for probability of C plus D greater than 11. We got probability of C plus D greater than or equal to 12. Lambda is 5.7 plus 3.9. Lower bound is 12. Upper bound, let's use 4/9. Answer is 0.259. Every drone that is hit earns Jordan 2 points, and every cruiser 6 points. Let T be the total points earned in 1 minute. Keywords: in 1 minute. Find E of T. T equals 2 times D plus 6 times C. This is given in the formula booklet. Therefore, E of D equals 5.7. Variance of D equals 5.7. E of C equals 3.9. Variance of C equals 3.9. Here is the formula given. So E of T equals 2 times 5.7 plus 6 times 3.9 equals 34.8. For variance of T, we will use this formula. This time, we have a coefficient variance of t equals variance of 2d plus 6c equals 2 squared times variance of d plus 6 squared times variance of c equals 4 times 5.7 plus 36 times 3.9 equals 163.2. Say, state one reason why the distribution of t cannot be Poisson. From this formula, we know for Poisson distribution, E of x equals variance of x. Here, E of t equals 34.8. Variance of t equals 163.2. Definitely, it's not a Poisson distribution because E of t is not equal to variance of t. That's the reason. Jordan intends to play the game for 1.5 hours. Use the central limit theorem to find the probability that Jordan's mean score per minute is greater than 35. For CLT, here's the rule. If it's not a normal distribution, you have to make sure this number of samples greater than or equal to 30. For normal distribution, it doesn't matter. X bar follows normal distribution with mu and a variance of x over n. Therefore, for this question, we know T bar because we are looking for mean score per minute follows normal distribution with 34.8 and a variance 163.2 over 1.5 hours is 90 minutes. So n equals 90. In other words, sigma equals square root 163.2 over 90. We are looking for probability of T bar greater than 35. Since this is a continuous distribution, you don't worry whether you have an equal sign over here. Let's go to normal CDF. Lower bound 35, upper bound infinity. Mean is 34.8. Standard deviation square root 163.2 divided by 90. Enter. Answer is 0.441.